Working with Data on .NET with Jeremy Likness.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host, for helping you and your teams move fast, deliver quality, and run your software with confidence in Azure, all while using everything the .NET ecosystem has to offer. And a lot of user groups are doing virtual presentations, and I've been speaking to a lot of those. So if you run a .NET or an Azure-related user group, reach out. I'd love to give a presentation for you. And this episode is sponsored by ClearMeasure. They make this podcast happen. They're a software architecture company, and they love to empower .NET teams to be self-sufficient and able to deliver world-class results. So if they can help, go ahead, get in touch. Also, check out the new video podcast, Architect Tips. And this is where you can submit a question and get your question answered directly. So today, I'm really excited about our repeat guest, Jeremy Likness. He's been on the show before last year, and he is a program manager at Microsoft for .NET Data. He's been at Microsoft for over 4 years, and he's an internationally selling author, a keynote speaker, a professional coder, and his personal mission is to empower developers to be their best. Jeremy, welcome back to the show. How are you, sir?
I'm doing great. I feel awesome that you actually invited me back. So hopefully the last show went well. But yeah, I'm enjoying. We've got some very beautiful, I guess, spring transitioning to summer weather here in Seattle area. So
fantastic. Well, I think that we have a lot of listeners who remember hearing you on the show. But for those who haven't, you've been at Microsoft for 1 year longer than when we talked last time, and Microsoft moves so fast, and the teams and the products kind of rearrange. What kinds of things does your current team do? .NET Data. Can you give us an overview of what that team is and what kind of conversations you have with your teammates?
Yeah, it's a very interesting role. I was a cloud advocate for my first 3 years at Microsoft. And that was an amazing role. I got to travel the world, go to major conferences, produce videos, write blog posts, build apps, and just everything I love to do as a developer and with developers and for developers. And I wanted to make a transition and do something more impactful. I felt like I could be reactionary in that role, but I wanted to actually drive change. And so I went looking at some different roles. I actually looked at marketing. I looked at engineering. I looked at a variety of potential positions, and this .NET Data role came up, which is a pretty exciting role. I'll tell you before I get into the mechanics of it, I got the offer for the role on a Tuesday. The next Monday, Microsoft campus closed. So during the interview process, I briefly stuck my head in a meeting room and saw the team and said, "Hi, I'm one of the candidates." But I have yet to actually meet with my teams in person, which is a little crazy, but it also is a testament to how this new kind of virtual reality, and not to be confused with virtual reality headsets, but this virtual meeting and everything has made things happen. But my role technically is the entire all-up experience of working with data for .NET. That's obviously too much for someone to just take in deep across the spectrum. So there are focus areas that I'm in. I work very closely with the Entity Framework core team and help drive requirements and improve the data and improve the experience there. I work with the .NET for Apache Spark team, which is bringing big data to .NET programming languages. And then I have some projects that kind of cross teams and cross areas. One that I'm super excited about is just taking a look at GraphQL and what's the state of GraphQL in the ecosystem, and what can we at Microsoft do to help with that. If that developer experience is less than stellar for whatever reason, is there something we can do to close that gap? So, the conversations I have day to day as a product manager are people happy with the product? Are there problems that need to be solved? If there are, how can we measure those problems? How can we provide solutions? And how can we measure success for those solutions and make sure we're on the right track? So it's not the same as just building a product, right? The software side of a product, it's bigger than that, but it's been a lot of fun for me and very rewarding, getting to do some very interesting things.
Nice. Now, how does the old common data service or Dataverse fit into that mix?
Oh yeah, I am working with that as well. So Common Data Service has been rebranded as Dataverse. And the concept, there's two parts to it. There's Common Data Model, and then there's what was Common Data Service or Dataverse. And Dataverse is designed as a enterprise data store that is designed to allow you to do what you need to do without getting in the way of things and without having to worry too much about what's underneath it. So in other words, you're not configuring a SQL server, you're not configuring Azure Cosmos DB table storage. You're dealing with a concept of entities. Those entities have properties like email, phone number. So part of what it does is out of the box provides validation for some of those common business concepts. You can create your own, but it also abstracts how it persists that data. So if I have a contact and that contact has a photo on it, I can deal with that as a byte stream going out and as a URL coming in and display that image. And it will handle, we're going to actually tag this in one database, but actually store it in Azure Storage without me having to do that. So I've been working with those teams. There's a very powerful portal experience. And what we're looking at is what does the development experience look like without going into the portal with the SDK and the API that's available? How can I build applications using those?
That's interesting. I've normally thought of Common Data Service as using it through Power Apps, but you're saying that more and more is being targeted by just use it from regular C# code?
Yes, there's a variety of scenarios, but I might want to build a MVC application or a Blazor application that has a set of functionality. And maybe it's a hybrid that I'm connecting directly to a database, but using Dataverse to augment that, or maybe it's an all-in Dataverse, and I just want the control and flexibility I have to use my standards, my libraries, and connect with that API on the back end. And there's an SDK that's available for it, but it also exposes an OData API. And what I'm doing right now is working with different OData clients to see what that experience is like of building a full application that allows you to create, read, edit, update, sort, and do that in an idiomatic way with C#, right? I don't want to have to manually roll an API call. I'd rather just use LINQ if I'm writing a query, those types of things.
Now, of those different methods of working with data in C#, what's the general distribution? Is there one of them that's got 80% of the time, 80% of .NET code is using one of these, but then these other methods seem to be, smaller adoption? Do you have any kind of sense for that, even if it's a swag?
Yeah, I have a little bit of sense because I do track telemetry to try to understand what usage is. The big thing is Entity Framework Core. A large percentage of developers use that. I'm not sure what numbers I can share or not share based on what we have on our end, but it's a significant amount. And it's something that, because we have such a large developer base, we're constantly making sure that we're tweaking and improving it. We just had a release back in November. I say just, right? This year's been flying by so fast. So it was a while ago, but November was EFCore 5. And EFCore 6 is something we're working on. And some of the themes that we focused on, for those not as familiar with Entity Framework or those who are, there's an Entity Framework that runs on the .NET Framework. The latest version of that, EF6, and not EFCore, but just EF6, actually runs on .NET Framework and .NET Core. So it gives a path for migration. EFCore is a specific version that was built from the ground up to take advantage of modern, cloud native concepts, modern development concepts. The old code base was a little outdated, so it was a re-architect, and the initial versions of that did not have as much feature parity with EF6. There were gaps there. And so part of what we've been doing is looking to close those gaps. So there's a very straightforward migration path if I want to move off EF6 and start taking advantage of the new bits. And part of it is looking at user requested features. Part of it is looking at important things like performance. In fact, we've got a pretty exciting performance story for EF6. We've been making tons and tons of improvements to the query pipeline and just ways, something as simple as, if you have logging, are we redundantly checking to see if we need to write to the logger versus doing something more proactive and checking it once and then going quiet if you're not receiving? But all of these tweaks have added up to substantial. I think the last public announcement we had, it was a 40 or 50% update, and we're optimistic it'll be much more than that, of performance based on the Tech and Power Fortunes benchmark. So there's a very standardized benchmark that we're using to baseline that progress.
Mm-hmm. Nice. Well, there's so many different .NET project types, and especially .NET 5 runs in all kinds of places, and then coming up in this fall with .NET MAUI, with .NET 6. And so is Entity Framework, so Entity Framework 6 is the latest, right? Or is it Entity Framework 5 that's currently released in the box?
The latest stable, what we would call stable release, or release to manufacturing, RTM, whatever, is EFCore 5.
Okay.
EFCore 6 will come out with .NET 6. EFCore basically maintains parity with .NET releases.
Yeah. And this is going to be a huge release, a brand new Visual Studio, and so this is going to be a big release.
There's a lot going on with this release. What's exciting to me is, since EFCore first came out, we focused on it, the cross-platform aspect of it, and really running on all the frameworks .NET runs on. And we're taking those stories that are kind of the edge cases. For example, mobile is one that there's some challenges with mobile because of the way EFCore optimizes what it does. And an iPhone, iOS, I should say, platform, you can't do certain things like dynamic code building, for example. So it can actually slow down those optimizations instead of them improving things. And so we're looking at how it's linked into that, what some of the options are, so that we can smooth out that experience and really make it light up across everything, with probably the exception of Blazor WebAssembly. You can use EFCore in Blazor WebAssembly. The problem is the databases you want to connect to, most of them are on protocols and ports and protocols that aren't supported by the browser. So unless it's a web-based protocol, it's something, although there is a port of SQLite to the WebAssembly platform that I haven't had time to spend, but it is something I want to look at and see that experience with EFCore and SQLite in Blazor WebAssembly. So
yeah, I think the Uno platform team has a little example of SQLite, but that's an interesting use case. Native apps are coming roaring back. I mean, back especially around the turn of the millennium, and then in the 2000 to 2010, tons of desktop apps, and then mobile. It's just another app. So maybe sit down desktop Windows apps. There's a lot of web apps that replaced them, but whether it's .NET MAUI on a smartphone or Blazor WebAssembly, there's so many times when the app starts up, we want to go grab a set of data, keep it on the client side, but then still have a familiar coding experience when I need to go and get a particular record. What's the go-to store on the client side? And then you still have Entity Framework kind of doing the query syntax, or is it the in-memory provider, or is there something else?
There's not really a go-to store. Most people might use a state management solution and deal with their objects as sort of state in the application. And then when they're actually querying, they do that over an API and have a client. I don't think there's a de facto yet for actually a local storage database. We've had people say, hey, do EFCore on top of IndexedDB or this, that, and the other. And these are certainly things we look at. We did a survey last year and got a lot of feedback about things people want us to do. Honestly, most of the applications I've worked with, I love the pattern of abstracting data behind a data access layer, whether it's a repository pattern or some other pattern. But you have some asynchronous hooks to say, give me a product or give me a list of products and let me query them. And then implementing that on the server as EFCore, for example, or if it's a heavy read app and you're just optimized for performance, you might use something like Dapper, which is completely fine. It's a very well performing product for that lightweight ORM. And then you implement that same interface on the client, only that's backed by a actual HTTP call that uses either REST or GraphQL or gRPC to communicate with the server. It'd be web gRPC. And marshal that data over. And that provides like a consistent pattern that whether you're on the client or the server, you're dealing with the same entities, the same interfaces, and you just implement them slightly differently in that model. And I'm a big fan of that. I wouldn't say that's the best approach or the de facto, but that's the one I've gravitated towards lately.
One of the new features that I've certainly put to use is the new inheritance strategies that they were in the old entity framework, but they kind of took a while to come to EFCore. Are those fully implemented and ready, or are there still some work to be done on those?
I would say they're implemented and ready from a perspective of using them, from a perspective of reverse engineering. There's probably work to be done to look at a database and intuitively understand how to model that relationship as part of your domain. But as far as a code first or what I call code in between design, where you've got the database design, you've got your domain, and you're just fluently mapping those. I would say the inheritance and the relationships are pretty solid with EFCore 5. I think there might be a little bit of work with some optimizations and tweaks going on in EFCore 6, but the many-to-many is one I love to demo because it shows how the implementation of that feature simplifies the code. You literally go from this really obnoxious, I'm building a pivot table just so that I can make my database happy. And so instead of contacts having meetings, meetings having contacts, they have this arbitrary pivot table, and then you navigate through that, which is what you had to do before. Now you can literally just remove all that code, and you can either ambiently, or I should say like as a shadow property, have that link table. EFCore will just create it in the background and you're hands off. But one of the other features with EFCore 5 is that you're not tied to a CLR type for database mapping. So in other words, you might map products to products, but there may be a set of properties that aren't on your product's model that are persistent to the database, and maybe you just map it to an iDictionary of string object so you can pull off and manipulate those products. Or maybe you have two different product models, and you can swap those out and basically get access to that pivot table when it's needed. So maybe you have a job that's running that deals with some metadata around that relationship. Do that there, but in your main application, you just have the simplistic model. So I love the freedom and flexibility it gives you. So there's that, and then there's the control over table per type and table per hierarchy, right? With being able to, and that's when people say, well, what's better, TPC or TPH? And it really depends on your data, right? Because the one method, table per hierarchy, says we'll store everything in a table and have a discriminator column for the type, which makes sense in certain scenarios. But if you have a lot of custom data per derived type, then you can get a really wide table, right? So you may want to then use table per type instead of table per hierarchy. And each type gets its own table. But then when you're querying, if you have, for example, a class that uses the base class as a collection, which is a very common pattern, that suddenly has to query across multiple tables. So you have to be aware of the trade-offs. I don't think there's the magic data bullet that can figure out everything yet.
Right. I think that a lot of developers are being exposed to different ways to model database schemas because of these ORM capabilities. Because you talk through that, and there's a lot of developers who are still, okay, wait, what the heck? What, table for class, table for type, table for hierarchy, and they're trying to get what the heck this is. And I remember, it was back in 2007 when Entity Framework was first coming out from the SQL Server team, and they announced, we're going to do an object relational mapper. And way back then, there were some open source alternatives like Hibernate and Wilson OR Mapper and Castle Windsor. And they had been ported over from the Java community. And so they were fully featured. And it was just a long time to catch up with some of the richness. But I would say now, when you look at this, it's like, oh man, there's come so far, and it works just so well, and it's so fast.
Yeah, that's a huge thing is the speed, and that's a big focus for EFCore 6. We're doing some things, and it's open up. I'm not saying we will use them, but there's the potential of source generators to do some precompiled things, and so there's a lot of tools in the toolbox. We found that just moving EFCore 5 onto .NET 6, so just moving to the new platform without any tweaks, gave us like a 5 or 10% boost in performance. Just that alone for the framework, and then tapping into new language features and constructs and things like that are helping us move forward with that. And a fun fact is Castle actually exists in the EFCore code base. So I'm pretty sure it's used to materialize some of the proxies
the
that do
dynamic
things.
proxy.
Yeah, exactly. So
yeah, that's been, that library's been used for 2 decades now, maybe.
Yeah, it's like the de facto. Yeah, if I don't want to go through all the steps to build dynamic objects myself through reflection, it's a great tool to do that.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
I would say that some developers are probably forced to learn object-oriented programming through some of these features as well, because if you want to have, like for instance, if you want to generate something to have lazy loading, well, then you have to have a proxy for a virtual property to have an association, and you got to know what's going on under the covers.
You do. And I think it's interesting because, I did 10 years of consulting in software before I came to Microsoft. And, 5-10 years ago, people would have thought you were insane if you said a lot of the way your database was managed came from code. It's like DBAs do the database, developers do the code side. And now we have people who are going so far as even writing their triggers in code because they're confident that there's no process that's going directly to the database. It's all going through the application, and they're perfectly comfortable having code drive the schema, the migrations, the updates, the business logic, the triggers, and everything. So it's a new world. And I think, some of that has evolved in the .NET ecosystem, but I think a lot of pressure from the JavaScript and open source ecosystem outside of Microsoft has driven that too. I mean, you've got solutions that were designed for JavaScript because it's a dynamic language. You can just take a object and just persist it without any ritual or ceremony with these, with the document database, which is another interesting thing because one of the most requested features for EFCore was in our survey support for MongoDB.
Oh, interesting.
So now when I call it an object mapper, I have to put relational in quotes because we support Azure Cosmos DB. Right. And now there's these requests for MongoDB. So
it may be relational or it may not.
Yeah, exactly.
Or typically you always have relational data, but maybe you have some data that's not relational. Right.
Yeah. And that's always the trick. Again, it's the same question we get, right? Should I go SQL? Should I go Cosmos? Which is better? And what's your data look like? I love that volume, variety, and velocity, right, of data to help kind of decide what you're going to use.
Mm-hmm. Right. Now, before we move off of Entity Framework, in builds and deployments, we're doing a lot of testing in DevOps pipelines, and inside the team and for all the various projects. How do you go about testing code that uses Entity Framework? For instance, do you use the in-memory provider, or do you still go to maybe LocalDB or SQL Express to make sure that you're using one of the data providers? How do you guys do that on the team?
Yeah, so we actually revamped our testing documentation. So if you go to docs.microsoft.com/EF, there is a document on testing, because it's been a huge thing is what is the way to test? And the answer is, unit tests are unit tests, database tests are database tests. The best way to test that your SQL is working is to test against a SQL server. Now, that's not going to work great for unit tests or tests that are at a lower level that you need to run quickly. So in those cases, in-memory is fine for a lot of scenarios, but it is not feature parity with the SQL Server. There's some link constructs that aren't going to translate the same. Another option is SQLite. But again, with SQLite, if you're testing, does link materialize the right query? That's one thing, but technically your date time field is going to be handled completely different on SQLite versus SQL Server. So it's still not an apples to apples. So what I end up doing is I usually do a lot of my testing with SQLite or in memory. And then if I have some integration tests, I'll do those against a actual SQL database. And then anything that depends on the services, that's when it becomes useful for either having a data access layer that you can mock the data interaction, or you can even put an interface on your DB context. A lot of people have asked us, why doesn't DB context have an interface? Well, you can create an interface and do an IDB set and completely mock that out. So I think there's options for that, but I would encourage people to check out that documentation, because it has samples that you can download and run that show. And a great way too, you say, how do we do it? We have, I don't know how many thousand tests that run every night. Our nightly builds go through the same testing scrutiny that a release will. A release is just with a stamp on it. And pulling down the source and seeing how we do the tests is probably useful for anyone. For example, Cosmos DB, right? We run that whole test engine without standing up a Cosmos DB account. We use the emulator, but the tests are smart enough, because the emulator right now is not cross-platform, that if the emulator is not present, it skips over that batch of tests, for example, for that environment.
That's a good point. And so which account on GitHub is the actual source available?
It's .NET/EFCore. So github.com/.net/EFCore.
Okay. Well, yeah, we'll put that in the show notes, because when people are putting together their private builds and the test suites, hey, there's nothing better than looking at something that's put together well and used for some really critical code libraries.
Well, the other thing too is we have a weekly status that we post. It's a pinned issue, so it's really easy to find. You just go to issues, you'll see that. And we do every other week a community stand-up. And we usually invite guests on, but sometimes the team does show and tell. And the most recent one, we walked end-to-end how to contribute a pull request to any framework core. So if someone is new to it or daunted by, like, I'll admit it, I've been developing for a long time. When I joined the team and I first pulled down the source, I said, there's so much here. Where do I start? But that video I encourage people to watch, because we walk through cloning the repo, running the tests for the first time, and actually make a change, test the change, write tests for the change, and then submit the change. So you see that whole process end to end.
Yeah. Awesome. I just pulled up Codebase. Really interesting to see the EFCore team uses ReSharper. I see the annotations in a lot of the code files. Yeah.
We've got ReSharper annotations. Several of the developers use Writer as their IDE. So it's a very open Microsoft, if you will.
Yeah. There's lots of great products. Now, can you talk about GraphQL a little bit? There's a ton of developers out there, even though that people start talking about GraphQL more and more, there's a lot of developers that have heard the name, but we don't know what the heck it is. So
sure.
What is it? And if you've got, .NET application, why would it be useful?
Sure. So GraphQL was born in the web on the front end to streamline speaking with the back end. It was actually invented at Facebook. And there's a quote from one of the inventors, I think his name's Lee Byron, but it was API that exposes a surface area large enough to control all of Facebook. So that was the idea. It's like one endpoint that can do everything. So what are the things that make GraphQL appealing? I've done a lot of interviews with people using GraphQL to better understand this. And fundamentally, the most appealing aspect of it for most people is something called overfetching, which it doesn't do. It avoids overfetching. And that's, you have a client, you have a limited set of APIs. So you want to get a list of products and you're only showing name and price, but you end up getting this fat set of records back from the database. And then I need a new endpoint that just gives me the data I need. So then you have the middleware or the backend developer write the new one and so on and so forth. So GraphQL allows you to basically, it's discoverable. So like WCF with WSDLs, like REST that's augmented with Swagger and OpenAPI. You can ask an endpoint what is available, but then it's very specific. You have a spec for a request, and that spec says exactly what that request wants. So I can say, I would like all of these products that have an order associated with them, and just bring me back the product name and the order quantity, for example. I can specify all that in a single request. So that's appealing. The other thing that's appealing is to two features of GraphQL. The way you handle requests is through something called a resolver. So there's a fragment of a request that comes in that says, I want orders. And it turns out products may be in the SQL database, orders may be over in a MySQL database or Cosmos DB or Mongo, some other database. So I can write a resolver for those parts of the query. And even though I'm asking one endpoint, I can still resolve those from other locations. And then on top of that, the second big feature is called schema stitching, which says that I may have multiple GraphQL APIs. So I'm an organization, I have Microsoft Graph, maybe I have product foo over here, maybe I have some other system, but I want to unify those and get out of having to keep service catalogs and indexes and everything else. So I just have one endpoint that stitches those back ends. A canonical example is you can take this restaurant API over here that's a public API for restaurants, and this weather API over here that's a public API for weather, and create an endpoint that says, show me the restaurants where the weather is going to be good tomorrow, for example. So it's cool in that respect. .NET has a couple libraries that support GraphQL. There's probably dozens. The two ones that seem to be most popular when I talk to people are GraphQL.net, which I have to give kudos for an awesome name, right? I mean, if you're going to do GraphQL for .NET and you can snag the name GraphQL.net, that's pretty good naming. And then the other one, which also gets an award for creative naming, is Hot Chocolate by a company called ChilliCream. I say a company, they're open source, but they provide support and whatnot. But what it looks like is like if I use Entity Framework Core, it's pretty easy because I'm already exposing sort of my schema, if you will, through my DB sets, right, are telling you which domain objects are there. So you can write an adapter or use an existing adapter that says, I want to take this EFCore data context and expose it as a GraphQL endpoint. And let me decorate it with some attributes that will allow it to do filtering, sorting, paging, everything else, and just augment that. That's what it looks like on the server. On the client, I can use a tool set to point to that server endpoint and have it generate a proxy for me that I just then go straight into the proxy and say, give me the products that just have the name and the price in them. And I get that list back and I work with it. So it is a pretty straightforward development cycle, but the key is on the client, I have total control over what I receive.
So walk us through the architecture with EFCore. That's a library. It runs in the memory space of your application. SQL Server is a different process that runs could be anywhere, and it could run in Azure. Is GraphQL a database engine or a library?
That's a good question. It's a specification for it's a query and mutation specification and runtime specification. So I would call GraphQL itself as more a specification than an implementation, and there's many clients and servers that implement it. So there's not a GraphQL library. I can use one library on my server to expose GraphQL. I can use a completely different set of tools on the client, but GraphQL specifies exactly what the shape of those requests and responses should look like and the features that a endpoint should support. And when we talk about features, things like being able to provide the data that's requested and no more, no less. Things like subscriptions, which are real-time streaming. So let me actually listen to this field and get notified as it changes. And then like schema stitching, right, is something that, again, there's not a library you get for schema stitching, but you have libraries that implement that part of the specification.
Okay, so if I have an existing, let's just say I have a .NET app running in app service, and I've already got Azure SQL. I'm up in Azure, and I want to get some of my data and use GraphQL. What is that, a new Azure resource, or architecturally, what would I do to adopt this?
Right now, you would visit your server project and you'd pick one of the libraries and you'd augment that project to surface a GraphQL endpoint.
Okay.
And so if it's an MVC app, it doesn't matter if it's running on your local machine or on Azure, because it exposes over standard HTTP ports. But I would basically say, here's an endpoint. For example, using Hot Chocolate, just because I've worked with that more recently, I would, in the service configuration, say use GraphQL, and then in the routing configuration, say map route, and I can take the default endpoint of /GraphQL or whatever, and now I'm up and running and I have an endpoint. So that is the change I would do to my server. Now, it sounds easy, but once you get to the authentication and different levels of security and access, you may need more configuration, right, to change what that endpoint exposes based on the context of the user. The client side is where it gets interesting, because if I'm writing a SPA application, there are tools like Apollo Client, for example, that I can use to point to the endpoint, generate TypeScript classes that are proxies that I just talked to in my TypeScript code to fetch data. There's teams who use it as creatively as even doing inter-process communication on the client using GraphQL endpoints. So every component just talks to an endpoint. If another endpoint happens to have that data cached, it'll just serve that up. Otherwise, it'll go to the server. So there's some cool optimizations that can be done. If I'm a .NET client, like a Blazor WebAssembly client, for example, then that's where I don't know the GraphQL.NET experience. I know the Hot Chocolate has a client tool called Strawberry Shake. You gotta love the names. But with Strawberry Shake, you have a tool that you install, kind of like .NET REPL tool or whatever. But you install a .NET tool, you point it to the endpoint, and it generates a set of proxies. Then you do what's called specifications. As you're writing your code, you know what you're going to request. So you add a file that says, this is what I'm going to request. That file will, when you build, generate all the code necessary to make that request. So you're basically going from, I'm talking to a REST endpoint, passing it parameters and deserializing JSON, to I'm talking to a proxy asynchronously asking for a list of these, product or product DTOs or whatever it is, and lighting those up. And where it's different from the REST experience is if I want to change how my REST endpoint behaves, I have to work on both sides, right? I have to, I want the REST endpoint to have an option to return 5 fields instead of 2. Well, I need to go to the server and tell it that. With GraphQL, once I stand up the server endpoint, if I want to change that request on the client, I just change it on the client and everything just works.
Yeah. Nice. Well, lots of ways to work with data on .NET. And there's
absolutely
probably going to be yet another option next year, I imagine.
I'm sure.
Awesome. Well, hey, Jeremy, I really appreciate you coming on the show and kind of enlightening us and sharing the work that you're doing in the team that you've been on for this past year. This is good stuff.
Yeah, thanks for having me back on. It's a lot of fun. And I would say to those listening, I'm very, very passionate about the experience with .NET Data. I know some people have great experiences. We don't often hear from them. So let us know, because the team loves to hear that. But obviously, if you're having a frustrating or tough experience, I'm available on Twitter. My email at Microsoft is my first name last name at Microsoft.com. Reach out to me. I want to hear from you. I'd love to talk to you about your experiences. You have questions about GraphQL. Let's start a dialogue and see what we can do.
Awesome. We'll include your email address in the show notes for people who want to get in touch. That's great. Thank you very much.
Awesome. Thank you.
And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.